Okay, number one. First thing is 16, 18, 20, 26, and 27. Those questions were gone over in class. Okay, so I will not go over those on this review. Okay, so um, I will be skipping those. All right, number one. Which of the following is an irrational number? Remember, irrational number key indicators for an irrational number, a non-terminating, non-repeating number, are if you see dot, 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 okay, or if you see the square root of an imperfect square. So, for example, the square root of 40, for example, okay? So those are your two situations where you see it's an irrational number. So which one of these are irrational? Well, 2/3, you don't see that, right? 2/3, if you take 2/3, it's 0.6 repeating, right? So this is 0.6, right? It's 0.6 repeating, okay? 4.7 has 4.7 repeating, okay? Square root of 16, the square root of 16 is 4, okay? If you want to double check and you're unsure about your perfect squares, hopefully you are, but if not, square root of 16 is 4, right? Okay, square root of 27 now, that's not a perfect square. You can't take the square root of that number and get a repeating number or a non-terminating number, right? So this is 5.196 dot dot dot. 5.196 dot dot dot, right? So there's the square root of the imperfect square, right? That is the irrational number, C. All right, number two, a park manager determined that the length of a soccer field is the square root of 8,156 meters wide. Approximate what is the approximate distance? Well, you know, you use your calculator to approximate this. So square root of 8,156, right? So the square root button is second x squared, right? That yellow, anything in yellow, okay? To access, you hit second. So 90.3, right? There's 90.3 meters. That's option A. Okay. All right. Number 3. Okay. So number 3, it's a division problem. The coefficients you divide, the exponents you subtract. 10 divided by 4. 10 divided by 4. Simplify the fraction. 10 over 4 is 5 over 2. And then you do 2 minus 8 for the exponent. 2 minus 8 is negative 6. So it'll be x to the negative 6. But, right, you don't want negative exponents in the end. Okay, so this negative 6, you're going to move it, and it becomes positive. The 5 stays at the top. 2x to the positive 6. This is what you want. 5 over 2x to the positive 6. There it is, option D. Okay, number 4. X squared equals 729. Which one is x squared? Well, you can kind of estimate here a little bit, but you have a calculator, okay? So 243, you know, that's going to be pretty big, okay? 243, if you make it 200, you got 2 zeros. 200 squared, you're going to have 4 zeros, right? So 243 squared doesn't give you 729, okay? So it gives us a number a lot bigger. So 364, you do 364 squared, is going to give us an even number even bigger than that, right? So 27, let's do 27. 27 squared. There's the x squared, right? Okay, so 729. 27 times 27 gives you 729. So C is the one that you want, okay? Number 5, the distance between the Earth and the Moon is approximately 240,000 miles. How is 240,000 expressed in scientific notation? So 240,000. So in scientific notation, we want the number between 1 and 10, the coefficient, right? So it's going to be 2.4 something. If we have the decimal right there, see how places it is away from where it started, right, or at the end. So if it's right there, it's 1, 2, 3, 4, 5. Okay, so it's times 10 to the fifth. Now we got to decide if it's positive or negative. The number that you started with, 240,000, is bigger than 1. Since it's bigger than 1, right, that exponent is going to be positive. Okay, so it's A. Number 6. All right, number 6. Which of the function which function the line of the scatter plot? Model the line of the scatter plot. So, there's a positive correlation here. You can draw a line of best fit, okay, through there if you need, that goes through most of the points. Okay, so it looks like the y-intercept, right? You got y equals mx plus b. The y-intercept is about 4. Okay, the slope, right, it's a positive 4, right? So look, the y-intercept, the b, should be 4. Okay, it's not going to be 1/2, right? The y-intercept is 4. So let's cross those out. The slope now, it's going to be a positive slope. Left to right, it's going up, right? So this here, right here, it has a negative slope. Okay, this is the one that you want. Let's test it. Up 1 over 2. Okay, 1 over 2. And notice each of these, they're counting by ones, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, right? So you can just count by ones here, right? So up 1 over 2, right? 1 over 2x plus 4. Y equals 1 over 2x plus 4, and then that's that one, right? Okay. Using the data to determine who has the higher unit rate. Okay, so if I look here, okay, it's telling you the unit rate. So first of all, rate, okay, Joe or Bob's rate is the slope. Okay, this is just slope. Rate and slope mean the same thing. Okay, so let's look at Bob's rate. Remember, the rate here is the change in y over the change in x. That gives you your slope. Okay, so let's go ahead and look here. Change in y is 40 cents, right? 40 cents to 80 cents. Difference is 40 cents. So it's 40 cents over, and the change in x from 1 to 2 is 1, right? So if you divide 0.40 or 40 cents divided by 1, the slope here is 0.40. Okay. All right. Let's look at the rate here. You want rise over run. Okay. So rise over run, right? It looks like uh, each one of these, it's broken up by 1, 2, 3, 4, right? So 1, 2, 3, it's broken up into fourths. So a fourth of 1 is 25 cents. Okay. So 25 cents. So every time it goes up, it's 0.25. Okay. 25 cents, 50 cents, 75 cents. Okay. So 75 cents over 1. So Joe's is 0.75 over 1, right? This is 0.75 is the rise. 1 is the run. Okay. So for Joe's, it's 0.75. That's the rate. Okay. And for Bob's, it's 0.40. Okay, so Joe's convenience store has the higher unit price. The following system, number 8, the following system of equations results in how many solutions? It's both of these are in y equals mx plus b form. The slope is the same. The y-intercept is different. Okay, so if the slope is the same, the y-intercept is different. Let's go ahead and say, here's the y-intercept, 1, 2, 3, 4, 5, 6. The slope is 4, up 4 over 1. 1, 2, 3, 4, 5, negative 5. The y-intercept here is negative 5. The slope is 4, up 4 over 1. Exact same slope. They have two different starting points. So the solutions are where the lines touch. These lines will never touch. These are parallel lines. Okay, so there will be no solution. You can also do this in the calculator, okay? And the calculator will graph these for you. Okay, you go to y equals, okay? And if I type in 4x, the x button is next to the 7, right? 4x plus 6. and then I go to the next one, 4x minus 5, 4x minus 5, okay, and I graph it. You look at the two graphs, those two lines never touch each other, okay, so no solution. Number 9, which equation represents the function below? Okay, so it looks like you want y equals mx plus b. B is the y-intercept. Remember, this is the m is the slope. B is the y-intercept. The y-intercept looks like it's 2, okay? Look at all these y-intercepts, positive 2, okay? So y equals, it's going to be a positive 2. Now you got to find the x. The slope, now you got to find the slope. The slope looks like left to right is going down, so it's going to be a negative slope, okay? So B and D both have negative slopes, okay? A and C then have positive slopes. Those aren't an option, okay? And then is it -1 or is it -1/2? Okay, no number there means -1. Down 1, right 1. Down 1, right 1. So the rise over run, okay, 1 over 1. Okay, so the slope, 1 over 1, 1 divided by 1, is 1. Okay, so the slope is -1. -1x plus 2. It has to be this one. Let's go ahead and check in our calculator here. Suppose I put in D, okay, and I tested this one out. -1 divided by 2. I put the x in, which is next to the 7. Okay, -1 over 2x plus 2, and I hit graph. Okay, look at where the y-intercept is here is 2, right? The x-intercept where it touches the x is also 2. This line doesn't touch the x-intercept at 2. Okay, so you look at the tick marks there, right? So these two aren't exactly the same. But if I put in B, okay, negative x, okay, again, x is next to the 7, negative x plus 2, and I hit graph, okay. Now this intercept is 2. You look at the tick marks, and also the x-intercept is 2. Where it touches the x-axis and it touches the y-axis, it matches exactly with the graph that's given to you. Okay. All right. Number 10. For number 10, solve the equation for x. Looks like a two-step equation here. 3x plus 4 equals 19. So I got to solve for x. -4 minus 4. 3x equals 19 minus 4 is 15. The last step is divide by 3. X equals 15 divided by 3 is 5. Okay, so 5 is what you want. Now, if I plug in, I can plug in and test. Okay, so in the calculator, if I test x as 5, 3 times 5 plus 4, 3 is 19, that works out. If I test one that doesn't work, for example, D, x is 6. 3 times 6 plus 4, 3 times 6 plus 4 gives me 22. I wanted that 19, so I know this one wouldn't be the right answer. Okay. All right, number 11. Without evaluating the system of equations, determine which of the following sentences is true about the system of equations listed below. Okay, so you have two equations here. Your options, it's pretty good idea to read your options first. There are infinitely many solutions because they are the same equation. There will be one solution. Not enough information, there will be no solutions because the coefficients are all different. So let's look at this here. If I look at these two equations, so both of these equations graph lines, okay? They're not in y-intercept form, slope-intercept form for you to graph it right now, right? But you know that these are linear equations, and if you graph them, they would graph a line. Now, notice the coefficients of the x's and the y's, right? The x and the y, or the x's here, 14, right? 14 is just twice as much as 7. 6 is twice as much as 3. 4 is twice as much as 2. Hey, if I multiply a 2 to everything in this top equation, 2 times 3 is 6. 2 times 2 is 4. I get the exact same equation back here. These two equations are the exact same equation. Okay? Since they're the exact same equation, if I were to graph two lines that were exactly the same, right, on the coordinate plane, one would be right on top of the other. There would be infinitely many solutions. Okay, so those equations, those lines are the exact same line. Number 12, which of the following is not a solution to 2x plus 3y minus 1? Hey, the first number in the coordinate is always x, the second number is always y. And the key thing here is which one is not a solution. So which one doesn't work out? Okay, so let's plug in. Let's plug in this first one. 2 times x is 3, so 2 times 3. Y is 2, right? So 3, and then the y is 2 minus 1. Okay, so I just plugged in y for 2 for y and 3 for x. 2 times 3 is 6. And then here, this is 2 times 3 is 6. 6 minus 1. 6 minus 1 is 5. Hey, 6 equals 5. That does not work. That's the one we want, right? We want the one that does not work. Okay, and certainly if you need help with the doing some of these with the calculator, for example, you're not good with your multiplication calculator if you need to simplify these, okay? All right. Number 13. All right, so the table below shows the total distance and the number of hours Tim rode his bicycle on each day. Based on the table, which day did Tim ride at the greatest average speed? Okay, so on Monday, he rode 38 miles in 2.5 hours. So let's find the average speed. Average is miles per hour. Okay, so we're just going to do 38 divided by 2.5. So on that day, he rode 15.2 miles an hour. Right, so here he rode 15.2. On Wednesday, he rode 30 miles in 1.5 hours. So 30 divided by 1.5. 30 divided by 1.5 is 20. So he rode 20 miles an hour. And then Friday he did 18 miles in 3/4 of an hour. 18 divided by 0.75, that's 24. Okay. And then on Sunday he did 40 miles in 2.25 hours. 2.25. Okay. 17.8. Okay. So miles per hour. Okay. Based on the table, on which day did Tim ride with the greatest average speed? So it looks like Friday is the greatest average speed. Okay. So he went 24 miles an hour on Friday. Number 14. This one, you can just multiply in your calculator. Okay. Just type it in exactly as you see it. 3.8 times, right? 2.7 times 10. Remember, the exponent button is the rooftop, right? To the parentheses, you get 10,260. There is 10,260. Okay. Number 15, which of the following graphs represents a linear function? Okay, so linear function, you're given a graph, do the vertical line test. Okay, so the vertical line test, okay, so if I draw a vertical line here, anywhere I draw a vertical line, it's only going to hit one point. Hey, this is a function, but it's not linear. Sorry. Right? It also has to be a line. Okay. So, anyways, that's not a line. It is a function, but it's not a line. B, this is also a function. Anywhere I draw a vertical line, right? It would only hit one time, but it's not a line. Okay. It wants a linear function. Okay. This is not a line either, and it's not a function. Right? I hit 2 points right there. So it's not a line, it's not a function either. D is a line, and if anywhere I draw a vertical line, it's only going to hit 1 point. D is the only linear function there. Okay. All right. Number 16 in class. Number 17. Margie is baking cookies. For a bake sale, she bakes 2 dozen cookies every 30 minutes and already has 240 cookies. The equation is y equals 4/5 x plus just and you see the rest of it there. What is the reasonable conclusion about the graph below? Okay, so the graph and the equation are the same. Okay, this equation represents this graph. So if you look down here, let's see which statement is true. 100 cookies in 100 minutes. Let's see, 150 cookies, 100 minutes. It's not 150 is not anywhere on here, right? She started off with 240 cookies. Okay, so 250 cookies, 150. So at 240 cookies, she's not even 50 minutes yet, right? It's, um, well, let's do it the other way. Let's do 150 minutes. 150 minutes. At 150 minutes, she has more than 350 cookies. So she definitely have 240. Okay. In 280 cookies. In 200 minutes, 280 cookies. Well, she had more than 400. At 100 minutes, 320 cookies. Hey, that's pretty close to 320. Okay, that's the closest thing there is. So that's why it's D. 18 we'll talk about, we've talked about last. 19, okay? So Maria was told that BD and EG, those lines, there's BD and EG, are parallel to each other, okay? And they're cut by this one universal. She was told that ACD is 60 degrees. ACD, this is 60. She was given that. And then she was asked to find all the remaining solutions below. Find which angle did Maria provide the wrong requirement measurement for. So remember we did this. This is the one that's given to her. So we want the vertical angle to that. Those are congruent. And then we want the two corresponding angles. They should all be congruent, right? So the corresponding angle to the one she was given is right here. And the one vertical to that would be right here, okay? Those circled ones should all be 60 degrees. Okay, this one isn't. Okay, EFH should be 60. Let's see, EFH should be 60 instead of 120. All right, this one should be C. Okay, that right there should be 60 degrees. Okay. 20 we did in class. 21, Joe is 10 years old and is 53 inches tall. According to the line of best fit, how does Joe compare to other children of his age? So this line, right, is the average. Okay, look at all the it's the line of best fit. The line of best fit is the average of all of those points. So at 10 years old, here's 10 years old, right? He's 53 tall. 53 inches is right there. So he is below the line. Okay, since he's below that line, right, he is below average. Okay. All right, number 22, a moving truck to be unloaded. It is often attached to a ramp. You know, looking at this one, I think I want to go over this in class. That one. Number 3, find the length of the line segment shown. Okay, so length line segment. Okay, so we're looking for that distance. Well, looks like we can use theorem because we can make a right angle right there. Okay. All right. So see how tall this is, right? 1, 2, 3, 4, 5. So this is 6. And then let's see how long is here. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. Looking for C, opposite of the right angle. This is A and this is B. So A squared plus B squared equals C squared. A is 6. 6 plus B is 8. 8 squared equals C squared. 36 plus 64. 8 squared is 64. 6 squared is 36 equals C squared. 36 plus 64 is 100 equals C squared. And take the square root. C is 10. Okay, and 10, that option right there. All right, number 24. Which of the following scatter plots is a positive correlation? Okay, so the line best fit, okay, should be going up from left to right. A, this is no correlation, right? You just see a blob. B, there is a correlation, but if you draw a line of best fit through it, the line is going down. C, it also looks like there is no correlation. D, looks like there is some correlation. If I draw a line of best fit through, it looks like it's going up. Okay, so D is your positive correlation, right? Positive correlation. Okay, left to right, line of best fit's going up. Number 5, which of the following scatter plots contain an outlier? So an outlier is a point that is very different from all the other points that are close together. The only one here is B. Okay, B has one that is way far away from all of the rest. Okay, so B is the one with the outlier. Okay, number 26. All right, so for this one, 26 and 7 we're doing in class. 28. Triangle DEF is a right triangle. Find the missing length. So we're looking for this angle right here. Okay, so it says it's a right triangle. Right there is our right angle. That means opposite of the right angle is, okay, and then the other two angles are A and B. Okay, so we're given C here. So let's plug in A squared plus B squared equals C squared. Okay, A is 12. So you got 12 squared plus B we don't know, and C is 37. Okay, so 37 squared. So 12 squared is 144 plus B squared equals, and then we'll take 37 squared. It is 1369. So we'll write 1369. And then we're going to solve for B, right? So to solve for B, it looks like we have to subtract 144. Subtract 144. So you get B squared equals 1316 minus 144. And that gives you 1,225. And then the last step is take the square root. Okay, so we're going to take square root second x squared, 1,225, and that gives us 35. Okay, so B equals 35. Okay. 29, company a producer of widgets that was founded in 1996. On initially had, but as it grew, the number grew as well. Use a scatter plot and line of best fit to estimate the number of new employees hired every year. So actually, they give you a scatter plot, okay, the line, and then they give you the table that goes with it also. This table and this line are the exact same thing. Look, in 1996, there's 10. 1996, there's 10, right? 2000, there's 25, right? So it's about it's the same information. So you can use either one to find the rate, okay, that the company hired. So remember, it's the rate, okay. The average, the rate, is also a change in Y over change in X. Okay, so the rate, or okay, average means the same thing as rate and slope. Okay, so let's take a look at here. Here's X, here's Y. Looks like the change in Y here is 15, 25 minus 10. Okay, so 15. And then the change in X, 2001 to 1996, that's 5 years. 15 divided by 5 is 3, right? So your average is 3. So the company XYZ on average hired 3 people per year. Okay, this was 15 and this was 5, right? Okay, so now next one, last one. Manny decided to save up all her money she earned during doing chores during May and August. At the end of August, she decided to make a scatter plot to help her analyze the savings. The number of months was represented by the x-axis. Okay, so and the amount saved was the y-axis. So the x-axis was the months, and the y-axis was the amount of money saved, right? Then after receiving her scatter plot, Manny decided to find the line of best fit for her data. She discovered the equation was she got y equals 20x plus 5. What does the 20 mean, represent in terms of Mandy's savings? So the 20 is the slope, right? Because there's your M. Okay, so the slope is a rate. So the rate is going to be in dollars per month. Okay, so she is saving $20 every month. 20 stands. So A says 20 stands for the amount she started with when she began. When she began, it would be the y-intercept, the B. So it's not that one. 20 represents the amount of money Mandy saved every month. That sounds it. Every month, the amount of money she saved. Okay.